Okay, I think we can get started. Uh, okay, I hope the quiz can be finished next week. So I will check the quiz. So next Monday and Wednesday, it will be TA class, a 2-hour TA class. So Monday and Wednesday. I will be teaching again the Thursday next week, and also Friday. And since we have, I think our quiz is 2 quiz, right? So if we need one more quiz, then I think we can make the quiz about this double integral. Maybe just like yesterday, maybe 3 questions or 4 questions, or maybe 3 questions. It's about double integral. So the final exam maybe around this, right? So final exam 22, and I hope after a few days I will finish the score, and I can send the score to all of the students. And maybe before I send, if we need some makeup test, and I think if we have still time, we can make it. But I hope everything will just fine, and after a few days I can just give you the score. So far, I think 1 or 2 students might like a little bit lower than the average, but I think averagely is okay. Like after the midterm and makeup midterm, I see the score still okay. But if there are some score that makes the average lower after finals, if I think I need the makeup test, then I will have the makeup test. But maybe for a few students that I think need the makeup. But if the score, maybe the gap is too wide, I mean the score is too low, and if I give the makeup, it doesn't really make a change. So I don't think I can help the student. Yeah. But for now, for average is okay. Average is okay. Only 1 or 2 students that I think too low. Okay, I think now I will just review and maybe practice how the double integral in polar coordinates will work. Okay. So basically what we did, or what we are going to do, is we are going to change this, basically change the r, okay, and change the dA. So the r, usually we have x and y. Now we need to make it into, this is alpha beta, which is the theta, okay, this theta here. And then a and b is the r. Okay. And then all the x and y is exchanging through this transformation. So r cosine theta for x and r sine theta for y. And then at the end, it's always in order, r, the theta, always in the order. Yeah, always in the order. So write this first, and then after that, when we solve the integration, we need to work one by one. Work from the inside and then the outside. Okay. So let's see one example here. So if we have this, okay, as our question. So of course, if we see the inside integral dy, I think it's easy, right? We just add y here, and then this will be y cubed over 3. But then if we put this endpoints inside, there will be, so if we try to force this, and then this will be, so let's say this is our first integration. So we write, this will be x squared y plus y cubed over 3. and we put 0 and we still have dx. Okay. Now if we put this square root over here, okay, to these two equation, so this will be x squared and then plus maybe this is, now we have a big chunk of integral of x. Maybe we can solve this, but I don't think, like, if we have limited time, this will be like take a longer time, right, to solve this integration. So usually if we could see from the equation, okay, whenever we see an equation that it can be convert into polar, then we can try to convert. And how we can see the conversion? First is we always remember that the r, we can write a circle, right? Or a polar curve. Okay. So whenever we can see this expression, or in here we have, this is x, right? This is for x, this is for y, which means that this will be y equal this, right? So we can also write this as y equal this. Okay. Or this is actually, if we squared both of this, okay, so this will be a circle with radius 1, right? With radius 1. So we could see that this part is actually can be converted into polar, okay? So this x squared plus y squared, it can be written as r squared. And the whole thing here, we can try to rewrite and try to build or draw the curve. So first we draw the curve from x equal -1 to 1, and then we draw from y equals 0 to the positive square root. Okay. If we get the circle, only the circle, if we draw this only the circle, it's just like a ball like this, right? Okay, this is a circle, right? But if we take the square root of this, we have positive and negative, right? We have actually we have positive, negative. If we take the square root, so this will be y equal positive, and this will be y equal negative, right? In our case, we only have the positive, right? We only have this, and start from y equals 0. So y equals 0 is here, right? So y equals 0, and then goes up according to this half circle. So basically, we can draw this the curve like this, okay? And this will be the x equal -1 and x equal 1. So from -1 to 1, and then take y equals 0 to the positive 1. Okay? So we draw the area first, the r. Okay? This is the area that is supposed to be integrated. And most of the time, in double integral or in the multiple integral in general, we don't care about what the surface will be, like the function, the surface. We don't care about how it looks like. We only care on the r, okay, the area below. So we only care about that. So now, if we take this and look into the polar, then this will be start from 0 degree, right? 0, and then we're circling this, and this will be pi, right? This will be pi of here, right? So this will be theta equals 0, theta equal pi over 2, and this will be theta equal pi. So we know that this will be 0 to pi, okay? And then how about the r? Now the r, since we have r is 1, only that r that exists in polar. So we can say that the r is from 0 to 1. So because we have the whole circle. If we say r is from half, okay, for example, half to 1, so maybe it will be having a whole. But here is no. So let me compare. Okay? So if we have another example here. Or let's say that is our circle. Maybe make it smaller. Okay, let's say we have that. And maybe if this is 2 over 3, and maybe this is 1, okay? And then if this is a whole, then this will be the solid area. Then the r is from 2 over 3 to 1. Okay? So you can imagine that this will be the area, and this will be another area. Okay? That's how we define the r and theta. So in here, we get that r is from 0 to 1. Okay? So basically, we are going to have a conversion. So let me write here. So first is the definition from the information given from xy. Okay, this is the information from the question. Right, and then we convert. So we convert and become a new r that is on r and theta. And this will be from 0 to pi and 0 to 1 for r. Okay. Now because of this, then the double integral from -110 of x squared plus y squared dy dx. This can be written as, first write the theta, the outside integral 0 pi, and then the r 0 1, and then the x squared plus y squared become r squared, and don't forget we need to multiply with r again, here r dr d theta. And now it's become really simple. Okay. So we can just integrate the r first, plug in, and then integrate with the d. Okay. But this one, because it's a constant, this two a constant, we can separate. Like you can do this first, or you can just integrate the d theta here, and this is pi. It's okay. So we can separate this, become this. So this will be pi r to the power of 4 over 4, or pi over 4 at the end. Okay. So the idea on the double integral in polar is how we identify a polar curve from the equation. Okay. So one understanding of the idea is to find whether we can have the r, which defines as the r from the circle equation. So whenever we can see that we have x squared plus y squared equals r squared, and we could see some of that changes in the equation, then we could convert them, and we could convert into the polar equation. And basically we are getting the new endpoints in terms of r and theta. Okay? And then just compute, and we can. And sometimes it will really makes the calculation simplified. Okay. So that's double integral. And yesterday I also joined the quiz, right? Did you join or not? Oh, yeah. Let me know your schedule, and we can have another thing. Because I think a few students also didn't come. Okay, so this is one example how to convert the double integral, okay, from xy to polar. Okay. Now I will give you more examples on the how the conversion will works with different example. Okay. So let's start another example starting from here. Okay. So this is, well, actually you can think from the question first, and then we can observe how it looks like in the graph. So it says that we have to find the volume. The solid is bounded from z equals 0, which means if in three dimension, z is on the vertical axis, this is x and this is y, and z equals 0 means the plane at the xy plane, right? And z equals 0, and then we have a parabola z, and it goes through the 1 minus x squared minus y squared. And you'll see that because we have this x squared and y squared, which easier to be converted into r, then perhaps this also can work as a conversion from xy to r theta. And then we can just start by just writing the volume first, and then just state that maybe this is r or d, okay? And this will be the parabola, the surface equation. And this will be just, let's just say dA. Okay? We don't really much care on what is dA, like dx dy or dy dx. It doesn't really matter. But the one that really matter is, it doesn't say any restrictions, like which point that is going to be evaluated, which means that we can just draw within all the area. So if you imagine a paraboloid will look like this, and it is going to be, the only restriction is only z equals 0, which means that this will be a full circle. This will be a full circle, and when z equals 0, then we get this endpoints on the ground, right? So when z equals 0, then this will be the equation, which is the circle with radius is equal 1. Okay, so this is a circle with radius equal 1, and this is a full circle, which means it's getting from 0 to 2 pi. So that's our endpoints for the ball. So we can write this. So the volume then, we could write, this is 0, 2 pi, and this will be 0, 1. Okay, let me write here the theta, and also the r is 0, 1, like that. So then the next step is, this will be 1, we can write this as 1 minus x squared plus y squared, right? Which is the r, right? So we can write 1 minus r squared. And don't forget, whenever we exchange xy to r theta, we need to write r, dr, d theta. And since the endpoint is a constant, then we can write this separately. So this will be d theta, and this will be r minus r cubed dr. So the d theta becomes 2 pi, and this will be half r squared minus r with power 4 over 4. So it will be half minus 1 over 4, which is 1 over 4, multiplied by 2 is pi over 2. Okay. So I think for the endpoint that is a constant, both of this double integration, I think the calculation will be not really complicated. Well, if the endpoint is another curve or another function, and then when some complication will happen, and we cannot separate this like this if this is a function. Okay? So this is another case, and another statement. So if we define the curve or the endpoints, like for example, we have some random here, and then we could see that this part of the curve is a function of theta, and another one here as a function of theta, and we would like to observe between this, okay? According to this theta from alpha to beta. Okay? So remember, now since we have converted the xy, we also need to change our perspective, okay, into the polar. Remember how we see the area in polar is stated by the polar axis, start here, and then we start moving like this. Okay? It's very different from the xy. When we see, like for example, the functions, oh, this is on the top, this is on the bottom, oh, this minus this, very, very, very clear, very easy for xy. But in polar, we always start from the polar axis, and this will be the first endpoint, and this will be the second one. Okay? Sometimes, if maybe the question is a little bit confusing or maybe a little bit complicated, sometimes it will plays with our mind, and we cannot really like distinguish between the xy and the polar. Okay? So remember, whenever we change, okay, xy and then change to polar, we need also to change our perspective. So this is how we could write. So basically, this r is in the function of theta. Okay? Maybe I will make it bigger. So let's try some examples on this part when we have endpoints as a function of theta. Okay, let's try this. Use double integral to find the area enclosed by one loop of the four-leaf rows. So it's not volume. So remember, we can also write and find the area using double integral. Okay. So remember, if you would like to find the area, we could find the area through double integral of some area D of just dA. So we say that if you remember, the volume is the base multiplied by the height. So we could say that the height is just 1. Okay? Just 1. And this is the area and multiplied with the height. Basically, the height is the function of the surface. So if we make that as 1, so we could say that this is actually the area itself. Okay, okay, now what we are looking for is actually based on just this polar curve, the rows. Now I believe the rows, if you remember, this is from chapter 10. So I think if you're not familiar with this, then perhaps let me give you the picture. What is the rows? This is the rows. Okay. The rows for cosine 2 theta. Okay. So cosine 2 theta. If you want to know like how to get the polar, maybe I will share some links that might be helpful for reviewing the polar coordinate and how we draw the polar coordinates, like the curve and so on. So it start from, if we start from, so polar is always start from theta equals 0, right? So if you take theta equals 0, it will be cosine 0, which is 1. That's what we have here from the starting polar axis. So this is going to be going here, and then going here, going there. Okay. That is, if you want to know more, like we can review chapter 10, but that will be taking time. But I think I will just give you some links to help you to understand. Basically, how we did this is we put the theta one by one and check. And whenever we find, because cosine and sine will have a negative, right? But in polar, can we have radius that is negative? Because this is radius 1, radius 1, radius 1, radius 1. Where's the negative? So the negative part is actually, so if the radius is negative 1, it will be 1 but in another side. Okay, so it requires some visualization. So it's at the very beginning it's like confusing, but if you keep on that as your principle, you will see that it will work for all the polar curves. Okay, so anyway, this is the area, and it says that we only need to restrict only one loop. So it has 4, right? The loop has 4, so we only care about this one loop. And this one loop, how do we know that the theta is pi over 4? If it's not given, how do we know this is pi over 4? Because at here, it's going back to the origin point, 0, right? The origin point is 0, I mean the R is 0. When R is 0, when cosine is 0, when is that? It's pi over 2, so pi over 4. Okay, get it? So when theta pi over 4, the cosine is 0. So R is getting back here. Okay? So if this has pi over 4, the other one should be having the negative pi over 4. This is the fourth quadrant. Or if you want to make it positive, you can say 2 pi minus pi over 4. Or just minus pi over 4. Okay, this one. So then we could get the theta between these two value. So we could write here, this is equal negative pi over 4 to pi over 4, okay? And then the inside one will be the R. What is the R? Since there are no other radius aside from the one that is given, the cosine 2 theta, then we will start with 0. So the endpoints start from 0 to R cosine 2 theta, or cosine 2 theta. So this will be the theta, this will be the R. Okay. And then the inside one will be R, dr, d theta. So usually, if you remember the chapter 10, we usually find the area by taking the integration by taking the theta, and the function itself is the polar curve, right, if you remember. But now we can rewrite that in double integration form. Basically, it will have the same area, okay, but this for different approach. Okay, so now we need to integrate the inside, right? Integrate the inside, which we get, this will be the same. So this will be half R squared from 0 to cosine 2 theta d theta. Okay. I will factor half outside, and then still we have negative pi over 4. I will put cosine 2 theta inside, so it will be cosine squared 2 theta, and 0 is 0, so it will be this. And this is the same as our area. Remember, in chapter 10, the area is based on half r squared, right? Half r squared. Right? So remember that in chapter 10, it's theta 1, theta 2, this will be half r squared d theta. Right? Okay. This is the one that we usually use. And it's actually, we get the same conclusion. Okay, now we need to solve this. How to integrate this? Going to check. Do you remember how? We have a square, but it's cosine. How to integrate? Do you remember? Yeah? Yes. So every time you have a cosine squared or sine squared, the best way to approach this is taking the double angle formula and then we are removing the square. Okay. So basically, let's say we have cosine 2x, we can write as 2 cosine squared x minus 1 or 1 minus 2 sine squared x. Okay. So here we have cosine squared 2 theta, so we have cosine 4. Okay. Now this will be 2 cosine squared 2x minus 1, or we can write as 1 plus, and we can write, and this will be divided by 2. Okay. So this will be 1 plus cosine 4 t divided by 2 d theta. So I will move 2 outside. It will be 1 over 4. And then we have 1 plus cosine 4 theta. I will integrate directly. This will be theta. Cosine integrate becomes sine 4t. Don't forget, if we integrate, we divide with 4. And then we plug in negative pi over 4, pi over 4. Actually, you can use the symmetric way. So this will be equal to 2 over 4 from 0 to pi over 4. So we only half and then multiply by 2. So this will be pi over 8. Or if you just want to compute this, it's okay, it will be the same. But I want to avoid mistake on this negative sign, so I'm taking, and I'm sure that it's symmetrical. So because the double integration in the polar, it will requires integration in sine or cosine at least. So this happens a lot, okay? So to solve it. So I hope you get this correct. Okay, another example, we have paraboloid. We have this equation. Okay. So if you are like curious how to design the curve, you could take y equals 0, you see the parabola. Take x equals 0, you see another parabola. So in some way in the 2-dimension zy, it's parabola. In zx also parabola. So it's parabola along the way. If we can imagine like this is z, x, y, every time we move, we see all parabola. So that's how we get this, the blue one. We get this. And then we have the cylinder. x squared plus y squared equal to x. So what is the question actually? So we need to find the volume. It's below this paraboloid, above the xy plane, okay, z equals 0, and then inside the cylinder. So we need to, like, before we get this picture, we need to know, like, what is this cylinder and how we can get the curve. So basically, if we try to solve this and find the circle equation through the cylinder, which we can do, we can take complete the square. So if we plus 1 here, we plus 1 there. So this will be x plus 1 squared plus y squared equal 1. So this will be the circle equation for the cylinder, right? Remember that cylinder means the circle equation in 3 dimensions. So which means that in every z, we always have a circle. So if we see from the top, it's a circle. But since we don't define any z in here, so which means that the z is along the way will be the same. Which we are going to see that as a cylinder like this. With the area, whenever we cut the cylinder, it's always the same circle. This is a circle with the center of -1 with the -1 0. Okay. Oh wait, I got it wrong. This should be minus. That's why the picture seems very wrong. This is positive. Okay, this is 1. Okay, so center is 1 0, right? So the center here, okay, 1 0 here. So you could imagine that the center is not the same as the center of the paraboloid, so it's a little bit different here. So we get that, and we see that it will cut this side of the paraboloid. And this is the one that we would like to know, the solid. So this will be the surface, the paraboloid surface, and then we would like to evaluate from this circle below until the paraboloid, the green one. Okay. So we would like to know this, only this this shape only, okay? And how to get this correct? How to get or how we're going to calculate? So this one will be our function on the top, right? That will be the z. And this one will be the area. So according to what we have in the volume, how to find the volume, we only care about this. And this one is the equation in the double integral. Okay. So at the end, we need to find the endpoint. Okay. You can think like this one as xy, but it's already in a circle, right? So we can just go move to r and theta. Okay. So we get this into r and theta, which means that we are going to get that since it is on the center 1 0, so I will just put 1 here. So this will be the center, and this will be the circle. This will be x and y. So this is the circle on the ground. Okay. Now we need to define what is this. What is the curve, right? So we can get it correct on at least 2 perspectives. The first perspective is if we convert this to polar, like if this is not xy, and we know like how much is this, like if we can have a circle here on the top, on the left, on the data. If we have right and left, the possibility is cosine. Is cosine theta minus cosine theta. In the top will be sine, the bottom will be negative sine. This is on this chapter 10, if you remember. That's on the polar curve. Now we have this, and we have this side here is 2. So this r is actually 2 cosine theta, just from visual. Or we could write from here. Okay, we could get it from the visuals or just changing the converted to polar. Okay. So I think we can have a break. I will continue this part. I believe that the conversion itself for the from Cartesian to polar is already takes some time, and you need to have like really have good observation on how to convert them. So let's make this a little bit smaller. I will make this small. Okay. And now we know how the polar is 2 cosine theta for this one. Okay. So if I change the circle, move here on the left, as I said, this will be negative 2 cosine theta. If I move up here, there will be 2 sine theta. I move down here, it will be negative 2 sine theta. Okay, there is I think some content from chapter 10 about polar coordinates and polar curves. Okay. Now we have r, and how about the theta? From theta equal what? 0 to 2 pi. Do you agree then? How to make this? If theta is 0, this will be the point, right? So if this theta is 0, it's 1. Right? So it will be on this point. Right? If theta is pi over 2, let's go here, right? I think we can just state that 0 to pi over 2 and multiply by 2. Symmetric, right? If not, then we need to start from this fourth quadrant. We start from negative pi over 2 until pi over 2. We could make that. Okay? Because this is not in the middle, so the angle will be different. So how do we know, or how we can confirm? Check one by one if you want. Like check from the very beginning, like theta equals 0, what will happen, and then what is the estimated area or estimated curve. So we increase the theta up until here, and I think we just need that, right? And then we multiply by 2 because of the symmetry. Okay. Now we could write down that the volume will be, let me write with d, okay, it starts from x squared plus y squared, this surface, dA, and we are going to have double integral, and the x squared plus y squared become r squared, and then r d theta. So let me just write negative pi over 2 first, I will change later. And then this will be from 0 to the r equal to cosine theta, right? So we can start to take this. Or we can write 2 and then 0 pi over 2 first, okay, just to make our calculation simpler. This will be r cubed. This will be r cubed, right? So we have, if we integrate, this will be r with power of 4, define of 4, and then this will be from 0 to 2 cosine theta. And then don't forget that we need to integrate again. So we are going to have 2 over 4 is half, so I will write half outside. And then the inside will be two cosine with power of 4 theta. Yeah, just that, right? Or this is should be this. Oh, sorry. 2 cosine theta and then power of 4 right there. I think this would be okay. And then I will factor out 2 with power of 4 is 16. I will move outside and it will be 8, right? So it will be 8. Maybe this will be going up. This will be going up like that. Going up. So equal 8. This will be cosine with power of 4 theta d theta. Okay, how to solve this? Now we have cosine with power of 4. Remember that most of the time what you need is actually just double angle for 1. But we have power of 4. Well, we can write cosine squared and then squared, right? So we can change this cosine squared with double angle. Okay, so we can write this as cosine square theta and then squared, right? The same, right? And we can change this, right? We can change this with double angle. Okay, so let's do that. So we might have like double angle inside double angle. Okay? So it will be 8. We change the inside, become 1 plus cosine 2 theta divided by 2 squared. And I will move these 2 squared, so 4 outside here, so it will be 2. So this will be 2. So we have 1 plus cosine 2 theta squared. We need to expand. Unfortunately, we need to expand that. 1 plus 2 cosine 2 theta plus another 1 cosine squared 2 theta. And all this need to be integrated with respect to theta. I think I will make this smaller. Okay. So this equal to, so I will write this as 1 plus 2 cosine 2 theta, the same. And the cosine squared, it will be another half 1 plus. Now we'll be having a cosine 4 theta, or I think we can write down around here. One plus cosine 4 theta. Okay. Now this will be 2, and we can integrate 1 by 1. So the inside will be, we have 1 plus half. I will directly just adding that become 3 over 2. So this will be 3 over 2 theta. Okay. And 2 cosine 2 theta will be sine 2 theta divided by 2. So the 2 will be cancelled. So plus sine 2 theta. And then we have the last one is cosine 4. So this will be half cosine 4 is sine 4 theta divide by 2 multiplied by 4 is 8. Okay, and then start to get from 0 to pi over 2. And the sign will be 0, right? The sign will be 0, pi over 2. Sine pi is 0, sine 2 pi is 0. So we only have so this equal 3 over 2 multiplied by 2 is 3 multiplied by 3 over 2 pi, so 3 over 2 pi. So this is the volume. Okay, so I think to help you get better to understand all of this, especially how to convert and how to I think the most important from all of this computation is the first one, how we can make sure that the endpoints are correct, our conversion are correct for the double integral in Poland. If we are not making this correct, the whole thing here will be like it's not in the right direction. Well, perhaps sometimes the most mistake like happens is you're getting there, the endpoints, but maybe a little bit different on the angle, okay, or even the curve. Maybe you get it, maybe not really correct curve, or you get it right, but somehow in the middle here will be very different calculation. So that's why I'm still giving you a chance to use calculator to check your answer. Especially the last part here, you can check using calculator. But I encourage just using calculator at the confirmation, because sometimes there will be some mistake also when you plug in the input in the calculator. Okay. Like if you do it in the middle, maybe your calculator will give you the wrong answer. So I think better to check the last one, just only the last one, to avoid like more mistake. And depends on the calculator. I think some calculators they can compute the multiple integrals, right? But I think the general one that you use, that the scientific one that I think most people buy, if you go to some like the general store, they have like the most abundant scientific calculator for high school, for university student. I think they don't have the multiple integrals mode. But I think the more expensive one they have. Even I think some of them they can compute some algebra. Yeah. Okay, anyway, I think I will give you more example and practice. Okay, so this notes I will compile and also put into the Moodle so that you can also check. So I have several examples here, also here. Then we only need 2 more examples. So let's take one from here, and then maybe the other one we take one. Okay. So any idea from 9 to 12, which do you prefer towards? Like it requires some observation on how the visuals look like, or how to imagine in the curve. That actually is one skill that you need to have for all the, I think most integrals. Okay, from 9 to 12? 12, okay. Do you want 12? You want 12? Okay. So I think, okay, this is the equation. R is the area or the endpoint. So R is the region that lies between the circles. So it has the circles that it has R is A, and the other circles is B, and then it says that the B is the highest one. So 0 less than A less than B. So this will be the radius. Okay. All right. So we could write down. Well, it's quite straightforward, as long as we keep our conversion correct. So which means that the x squared plus y squared is r squared. And remember that we have only 3 conversion actually. So x is r cosine theta, and y is r sine theta. Only these 3. Your tools for conversion is these 3 equations. So we have. Now let me write again. This will be r y squared x squared plus y squared. So they are all a circle, right? So they are all circle. So the r is a circle. So it doesn't mention any specific angle. So we could assume it will be a full circle. Okay. So this will be the a. So we can assume that they will be starting from 0 to 2 pi for the angle. And how about the radius? It's stated that the radius is A is less than B. So we can say the radius will be from A to B, okay, for this circle. So if you want to like imagine what it looks like, the region, it looks like this. So this will be A, and this will be B. So only this area. So this will be the R. And then the equation inside we change into the conversion. So this will be squared, and this will be r squared. So we are going to have some cancellation. Oh, don't forget the r, dr, d theta. So we are going to have, let me write, this is a, b, r squared will be cancelled, so we only have sine squared theta, r, dr, d theta. Okay, now remember, a and b constant, right? So we can separate, like, we only take this theta with the d theta and r with dr. Okay. So we take that and separate both of them. So taking the 0 to pi, or maybe move a little bit left here. This will be sine squared theta d theta, and this will be a, b, r, dr. And this will be equal. Now we have sine squared. Remember that we need to take double angle, so I will write half outside of the integration. Then we have 1 minus cosine 2 theta d theta, right? And then multiply with, maybe I will just directly integrate this, become half r squared from a to b. Okay. And this become half theta I think maybe just to be safe, let me just write here. Okay. I worry if I make a mistake here. Half. Okay, I think I'll click. So this will be negative sign. This will be half. This will be 0, so 2 pi divided by 2 is pi, so pi over 2 b squared minus a squared, right? The rest is 0. Okay, that's it. Maybe any questions from this part? If question like this happen in your exam, can you do it? I think okay, right? Still okay. It's okay. I think the more complicated one, I think the next part of the questions that requires good observation and some mastery of the polar curves understanding. For the circle one, I think most students will understand the circle one. But if the curve is in another polar curve, like maybe the rose or any curve that in terms of like the polar curve that we have. Like we have the cardioid, if you remember that. That is also polar curve. That maybe some complexity will happen. Okay, now you can try this, but I will move here. So we have two set of questions. Maybe one question from 29 to 37. And the next one will be this 34, yeah, this one, the rest. So maybe this 29 to 33. Any idea which one? So we have 29, 30, 31, 32, 33. 33 is just like a sphere of radius A. We need to know like what is a sphere and how do we write the sphere. Sphere, if you remember, we have the ellipsoid. It's just the same with ellipsoid, but in sphere, usually we have the x squared over a plus b squared over y squared over b, right? So a, b, c is just one, and that will be becoming a sphere. Any idea which one? 30 or 31 or 29?
30.
30?
Yeah.
30, okay, 30. So we have a cone. We have a cone, okay, z equals square root of x squared plus y squared. And it says that we have a ring, okay, ring. So if you see that x squared plus y squared, we understand that it will be r squared, right? R squared. So you can see that this will be radius from 1 to 2. Okay, so just by looking at a glance of the equations. Now we need to set up. We need to set up the volume for this one. So it's actually, we could write, so number 30. So we have v1 less equal x squared plus y squared. So we have r is from 1 to 2. And then it doesn't say anything about the like restriction on angle. So we can imagine it will be just a full circle. Okay. So we could write the volume. We could write first in terms of, let's say this is r, this is the square root of x squared plus y squared. So we take z as a surface function of xy, and this will be dA, and this will be equal to taking from 0 to 2 pi, and then taking from r equal 1 to 2. And I think there is no mentioning about anything else, right? So we could directly write that since z is in terms of square root of x squared plus y squared, so we can write this will be square root of r squared. So r dr d theta. So actually it's not really that complex, have a complexity in the calculations, but we need to be careful. And since both integral are constant, we can separate. So this would be r squared dr. this will be 2 pi, and we have r cubed over 3 from 1 to 2. So 2 pi, this will be 8 over 3 minus 1 over 3, which give you 7, right? 7 over 3, so this will be 14 over 3 pi, okay, the volume. And if we understand, so we don't really need to draw, because we understand like this is a full circle, this is the cone, so we can just directly write the equations. But if they have some complexity, like we need to find really which one is the endpoints, sometimes we need to draw. And it doesn't mention like we need to draw or anything. So you can directly write down the equation and compute. So we have a cone and we have a flat, the plane, the ring, right? Flat. If we have some surface and we have another surface, that will be a problem. That we need to think first to find the intersection between those two. Like other questions, I think they will need to take how to make sure that we get the intersection and we get the endpoints. Okay, maybe another question from 34 to 37. Which one? No, this is worthy for to be in the exam. I think like one from the previous one and one from this. So need to be balanced. You have something that is straightforward, and you need something to be like you need to have like good analytical skills. How about the 34 to 37? Which part that is? 35? Okay, or 6? All is not okay.
36.
36? Okay. So it's interesting. We have the paraboloids, z equal this, and we have another one, which is this. So we have two paraboloids. So it's not the same. Like before, we think like, oh, we have a surface, and the below, the area below is a flat, right? So it's like it's easy to understand. But this another surface. Right? So it means that. Let me write here. Oh, actually, there's another question here. Okay, let me check this 36. Okay. Maybe I will make this go up a little bit. Make sure that we have enough space. Resize. Maybe go ahead there. And maybe let me write on this one. So 36. So first is, if we have a two surface, so let me write here, if the volume bounded by two surfaces, then need to check the intersection. So let me write the, what is the equation? C. And then Z is, so this is two paraboloids. So how to take the intersections? So take the equaling both Z, okay, because we know that the surface is a function of two variables x, y. So their Z, when they are equal, they will at least going to have some intersection at some point. Okay? Like maybe like this. Okay? So we want to find like in which points. Like maybe if I draw here, like we have that, and we have another below. Okay, but imagine that this will be 3 dimensions. Okay. All right. Now if we take 6 minus x squared minus y squared, is equal to x squared plus y squared. So this will be x squared plus y squared, or 3 equals 6, or x squared plus y squared equal 2. So which means it's this circle. So when they, like, this is paraboloid, this is another paraboloid now. So they are creating a circle at the intersections. Okay. So they are actually creating a circle here. So that is the intersections, okay? Which is the x squared plus y squared equal to, and how this will be important. So this will be our endpoints, okay? So let me write maybe here. Let me resize first. Too big. So the volume, let's say R, the volume is 6 minus x squared minus y squared. Maybe let me write the volume here. So minus 2x squared plus y squared, okay? And of course, how do we know that the 6 minus x squared minus y squared is on the top, and this will be on the bottom? That requires knowledge from the quadratic surface. Or you can trace one by one, taking the x equals 0, so we have minus y squared. How will be minus y squared? So if it's x, y, this is z. So if we see z and y, it's like y like x in y x. So this will be this or this. So keep in mind, if you have like y equal x squared in 2 dimensions, it's always this, right? X squared. So if you have the minus one, this, right? So whenever you have like minus, you have a paraboloid, which give you this, okay? If you have a positive, it's give you this. So of course, this one will be higher. You can check, like, play with the points, okay? Play with some points, and to make sure that, okay, this will be the highest one on the top, on the surface. So this will be going to be top minus the surface on the bottom. Okay? This is the bottom surface, okay? The top surface. So top minus bottom. And then we are going to evaluate which one is the endpoint. So we get that the intersection between these two are our circle, which radius is square root of 2, right? Square root of 2. So the radius, because there's nothing mentioning about restriction on radius, we could say the radius is from 0 to square root of 2 for the radius. Okay? Or maybe right on that one. This could be 0, r, okay? And because there's nothing also on the theta, we could also assume theta is going to be full circle. So we could exchange all this theta and r, and writing the 0 to pi, 0 to square root of 2. Okay, and then this one, I think we need to compute this first. I forgot. Let me write there. So 6. So minus x squared minus 2 is negative. So 6 minus 3x squared, and then minus y minus oh, I think I got it wrong. Wait. It should be not y squared 2. But I get it correct here. Oh. Okay, it should be like that. Okay. So this will be plus 2y squared. Okay. So this will be 6 minus 3, right? Minus 3y squared. So this will be 6 minus 3 x squared plus y squared. So we can change the x squared plus y squared with r. So 6 minus 3r squared. This is r, dr, d theta. I think we can separate d theta. So we could write v this will be 6r minus 3r cubed. 2 pi, this will be what? 3r squared minus 3 over 4 r to the power 4. Plug in 0 to square root of 2. So this will be 6 minus square root of 2, squared is 2, so 2, 4, 3, right? This will be 6 pi. So we have several types of question. There are something that is direct, and then sometimes we need to have requires us to understand how to at least visuals how it looks like, and if you can draw it, maybe it will help. Okay. And also there are another one that looks like this. So you are given directly the equations. Like you have the double integrals, you have the endpoints, you have the equations, and whenever you have something like this, like square root something like that, you need to be aware. And then you must be cautious. Oh, this must be need conversion. If not, if you directly integrate, sometimes you will not be able to do it easily. Maybe the first one easy, like this one. Xy squared dx, oh, it's easy, dx is x squared over 2 y squared, okay, easy. But then you have this endpoint. Maybe not so easy. Maybe we need to convert to polar. Okay, before this, any question on number 36? Any question on this one? It's actually quite complex. You can try another one like 35 or 37, or even 34. And you need to understand maybe 34 paraboloid blah 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 in the plane z equals 7 in the first octant. The first octant means in 3 dimensions we have 8, 8 space. In 2 dimensions we have 4. One. If we remember, in 2 dimensions we have 1, 2, 3, 4. The quadrant in the trigonometry. But if in 3 dimensions you can imagine like this, and we have 4 spaces, and below is another 4, so 8 spaces. The first octant means it is on the first space, which is all will be in the positive. Okay. All is positive value. And usually they will ask first octant, because if the question asks you the third octant, and you will be confused which one is the third one. So usually it's asking the first, which means that every value in that space will be a positive value. I check all the textbook. There are no question asking the second octet the third or no. Only the first octet they will be asking that. Which means that all value will be positive. Okay, yeah, we still have like 10 minutes left. Do you want one more or end the class? Do you have to end or one more? I know this is Friday and then rainy, right? It's quite sleepy. Or let me just give you first and then we can continue later. Is that okay? Or if you have any questions, we can discuss. Yeah.
But we stop at chapter 15, right?
Yes, 15. And 15 maybe not all. So after this, we still have the surface area, and I think we need to go to the Jacobian first. That's the last section on chapter 15. And if we have time, then go to the triple integral. Okay. And in the triple integral, there are also another conversion. We say the cylinder coordinates and the sphere coordinates. It requires another conversion. So not only the r theta, but you will have the phi and then another angle. So imagine that we have like this is double, right? That is triple integration. Okay. But that is if we have time. But if not, then just the normal triple integral x, y, z. I think we can get through the triple integral at least. Okay. Yesterday quiz, okay or not? Okay, right? I saw like at least half student. I think 60% or 70%